Hello everyone, and welcome back to my SP2 channel. In this video, we're going to be looking at formula weights and the elemental composition of substances. I have a little bit on kind of formula and the molecular weights, how we can do the calculation for the elemental composition, and at the end I have a practice for you. Okay, so let's get started by formula and molecular weights. For the formula weight of a substance, that is going to be the sum of the atomic weight of all the atoms in the chemical formula of the substance. For example, for sulfuric acid, H2SO4, that is going to be 98.1 atomic mass units. So let me show you how we got that. When you're looking at your chemical formula, H2SO4, we expect to get 2 atoms of hydrogen, 1 atom of sulfur, and we also have 4 atoms of oxygen. You can use a periodic table to find out the atomic weights for all of these elements, which is going to be 1, 32.1, and 16 atomic mass units for hydrogen, sulfur, and oxygen, respectively. You can plug them all here, and you can sum them up, and that is going to be 98.1 AMU. Now keep that in mind. If the chemical formula is the chemical symbol of an element, for example, for sodium and A, then the formula weight is going to be equal to the atomic weight of that element. So for sodium, this value would be 23.1 AMU. Also, if the chemical formula is that of a molecule, just like what we had for sulfuric acid, then the formula weight can also be called the molecular weight. Okay, now we're going to be looking at the elemental compositions. So let's say you are a forensic chemist working in a crime lab, and you actually find a mysterious white powder at a crime scene. Now, here's the question. What is this mystery powder? Is that salt, sugar, maybe cocaine, or something else, right? So one way to determine the identity of a substance is to measure its elemental composition and then compare that to the calculated elemental compositions of possible candidates for that substance. We need to follow this equation here. As you can see, it says the percent of the mass composition for each element must be equal to the number of atoms times by the atomic weight of that element, and then you divide that by the formula weight of your substance, and then you need to times that by 100 because we'll try to get the percent, right? And then keep that in mind when you sum all of these mass percentages of each of these elements, that must be equal to 100%. Okay, so let's take a look at an example. So here it says calculate the mass percentage of sulfur in sulfuric acid. Based on atoms, we can see that for each H2SO4 molecule, 1 atom out of 7 is sulfur. But that doesn't mean that we're going to get 1/7 of the mass of this compound for sulfur, because these atoms are going to have different masses, right? So we need to follow the equation. We're looking for the percent of S in H2SO4. There's only one S, right? Times by the atomic weight, which is 32.1. And then we divide that by the formula weight for sulfuric acid, which is something that we just calculate that in our previous slide, times by 100, and that is going to be 32.7%. Which means that when you're thinking about this value, 1/3 of the mass for any given, quantity of sulfuric acid is going to be sulfur. Okay, so let's take a look at our first practice. So here it says calculate the formula weight of sucrose. We also have the chemical formula, which is C12H22O11. And actually, this is our table sugar, right? So our job is to add all the atomic weights of the atoms that we have in sucrose, right? Okay, so here is the math. You've got 12 carbon atoms, which is going to be 12 by 12 AMU. We have 22 hydrogen atoms, so that will be 22 by 1 AMU. We also have 11 oxygen atoms, right, which is going to be 11 by 16 AMU. And then you just add them up, and that is going to be 342 AMU. Okay, so take a look at the second practice. Calculate the percentage of carbon, hydrogen, and oxygen by mass in C12H22O11. For carbon, we have 12 atoms. We times that by the atomic weight, which is 12, and you divide that by the formula weight times by 100, and that is going to be about 42%. You can do the same thing for hydrogen. That's going to give us 6.4%, and for oxygen is about 51%. Thank you very much for watching this video. If you found this video helpful, please don't forget to give it a thumbs up, right? And you can share that with your friends. If you're enjoying the content and you want to kind of keep learning with me, you can hit that subscribe button. You can turn on your notification bell so you're not going to miss out any of our future lessons, right? I told you many times, I love to hear from you guys. You can drop a comment below if you have any questions or you have a specific topic that you would like me to cover in our future videos. Your support means the whole world to me and it helps this channel grow. Thank you again. I'll see you on the next one. Bye for now.